Hello, this is our week 2, day 1 boot camp video on solving equations. And in week 1, we solved them with the sketch method. So week 2, we're going to transition to solving algebraically. Now, when we solve equations algebraically, like the one we've got down there, 4x plus 5 equals 2x plus 9, instead of drawing all the pictures, although I'm going to show you that, we use opposite operations. And that's important to remember because when you're doing things with algebra, you have to use opposite operations. So when we do that, we're going to, if the problem is connected with addition or positives, then we use subtraction or negatives in order to isolate our variable, get the x by itself. If it's connected with multiplication, then we're going to use division. And the other thing is we're going to use this essential rule of math up here, which talks about both sides. We can do anything we want to the equation as long as we do it to both sides. Right now, this equation is balanced. It's equal. That's what it says. It says that the 4x plus 5 is equal to the 2x plus 9. Our left side is equal to our right side. So if I wanted to, I could add 10 to the right side, but then it wouldn't be balanced anymore. In order for it to be balanced, I'd have to add 10 to the left side. Now that might help us solve the equation, it might not, but as long as we do the same thing to both sides, it maintains the balance. We haven't actually changed it. Everything is still equal. So that's one of the things we have to remember to do is to make sure we do the same thing to both sides and we use opposite operations. And the method that we're going to use to do this is called the DCID method. It stands for distribute, combine like terms, isolate through addition or subtraction, and then divide. And actually the last two steps are both isolate steps, is that if we have to do an isolate step that involves addition or subtraction, we do it before the division step. Now, for today, we're actually not going to be doing the distribute, so I'm just going to put an X there, or the combine like term steps. You don't always have to do every single step on every equation. It depends upon how the equation is set up. But if you do have to run through all the steps, this is the order to do them in, except for that today there's no parentheses, so there's no reason to distribute, and there's no like terms. Those will be in later lessons. We're going to be looking at these last two steps first. So if I look at problem number 1, 4x plus 5 equals 2x plus 9. And what I am going to do is I'm going to sketch it down below so that we can sort of see how the two methods relate to each other. So before I would do 4x, so our x's are triangles, so 4x's and a 5 cube. And then on the other side, 2x's, so two triangles, and a 9 cube. The number without the letters are the constants, so we do the cubes. So that's the visual sketch representation of our equation. Now remember, even when we did it visually, the thing that we wanted to do was to get the triangles on one side. The triangles are the x's. You want to get the x's on one side and by themselves. So that's why we say we need to isolate, because my triangles are on both sides and I have cubes on both sides. Well, if I look up at the problem the way it's written, I have x's on both sides and I have constants, the numbers without the x's on both sides. And that's not the way I want it to be. I want x's on one side and numbers without x's, constants, on the other side. So that's the isolate step. Now, if we look at how we did it originally, down here at the sketches again, what we did was we said, well, if I've got triangles on both sides, I can take off triangles. And I could take them off one at a time like this, as long as I did it to both sides. Or I can just say, hey, you know what? I've got 2 triangles on the right and 4 triangles on the left. I can take away both triangles on the right, as long as I take away both triangles on the left. You can do it all at one step. It's the same sort of thing algebraically. We're going to go to the side that's got fewer x's. Remember, triangles are your x's, and I always like to deal with the x's first. So 2x's is fewer than 4x's. So I can say, you know what, I need to take that off of that side, and if I take it away, that's a minus. But if I take it away from this side, I have to take it away from the other side, And notice I do line it up with the thing that I'm taking it away from. I'm taking it away from the 4x's or for the 4 triangles. And you might ask, well, but why am I taking away versus adding? Because this isolate step down here had both plus or minus. Well, it depends upon how it's connected. If you look up out here, that 2x that's in the original problem, that's a positive 2x. Positive, think of that like a plus. And remember, we use opposites. Well, the opposite of the plus is the minus. So that's why I'm going to minus that 2x there. And so then I say 2x minus 2x is 0 x's, so then that's gone away, just like it went away in the picture. There was no triangles left on the right side. But on my left side, I can just subtract. 4 minus 2, or 4x's minus 2x's is 2x, just like I had 2 triangles left. And then if I was looking at the sketching, we would re-sketch so that we would say, okay, I've got 2 triangles left here, but then I also re-sketched whatever else was left. I also had the 5 cube left, and I also had the 9 cube left. Well, I'm going to do the same thing algebraically. I'm going to say, okay, I subtracted and got my 2x, but I'm going to bring down the plus 5 because it's still there. And same thing on the other side, I'm going to bring down the 9. You do not have to put the plus in front of it because without the plus sign, it's understood to be a positive 9. But now going back to our cubes, we said, okay, I can't take off any more triangles, but I do have cubes on both sides. So I'm still isolating. I'm still trying to get the triangles by themselves. So I'm going to go and I'm going to go to the triangle side. I'm going to take off that 5 cube. But if I take away the 5 cube from the left side, I've got to take it away from the right side. Well, we're going to do the same thing algebraically. You always want to get this x by itself. Well, there's a 2 connected to it and a 5. So we need to get both of them away. But it's like, well, which one do we do first? Well, when we did the sketch, we did the 5 first. That's because the 5 is connected through addition. We can see the positive, the plus sign up there in the equation, and also it's a positive 5 down here. And remember, we do this isolation step. If it's got a plus or a minus, we do that first. So that 5 is what I'm going to take away first because that 2 is connected through multiplication. That's a 2 multiplied by x. And we do the isolate with the add and subtract. We do those first. So I'm going to get rid of that 5 first. And once again, since it is connected through addition, I'm going to use subtraction. So I'm going to subtract to opposite, and 5 minus 5 is 0. So then it goes away just like it went away over here in the visual sketch. But then I have to do it on the right side as well. And then I can say 9 minus 5 is 4. But then just like I brought down whatever was left, I still need to bring down whatever's left. So I've got a 2x left. And if we look at it sketch-wise, we can say, okay, I've got my 9 minus 5 cube, which would be the 4 cube, and I've got 2 triangles left. So it's the same thing here. Now this is where it gets different from the sketching. In the sketching, we would use the guess and check to try to decide what number would go here. But we don't have to use that if we're doing it algebraically. I can't just take away things anymore like I did. I don't have x's on both sides. I don't have cubes on both sides. But I've got this 2 connected to the x. Now the 2 is not a constant. It's not a cube. Okay. It's actually what's called a coefficient. It's a number being multiplied by a variable. So since it's connected through multiplication, 2 times x, the opposite of multiplication is division. So I'm going to divide. So I'm going to divide this side by 2, and 2 divided by 2 is 1, so I end up with 1x. But if I divide on the left, I have to divide on the right, and 4 divided by 2 is 2. So then I have 1x equals 2, but you don't actually have to write the 1. That can become part of your box. So I've got x equals 2. And if we come down here to how we were doing it with the sketch method and say, okay, well, we're saying x is 2. X is the same thing as a triangle. And so we put it up there where the triangles were, and then we were adding them together and saying 2 plus 2 equals 4. Oh, and yes, it does. I got a 4 on this side. I got a 4 on that side. It balanced. So my answer really is x x equals 2. And you can see how you get the same answer both either algebraically or visually. Because here we've got one triangle equals 2, and a triangle is the same thing as your x. So x must equal 2.